Hey everybody, Dr. A here, and in this video we are going to be providing some background information on shallow foundations and what is categorized as a shallow foundation. So before we get into that explicitly, what is a foundation in general? Well, in structural engineering and geotechnical engineering and really civil engineering in general, a foundation is considered something that is supporting something above it. So we think of a foundation as usually a type of concrete pad or concrete shaft that's embedded in the ground, in the soil, that is holding up something above it, usually a structure. Maybe that's a building, maybe that's a bridge, for example. So that's what we call a foundation. Now, foundations are typically categorized as either shallow or deep. So we have shallow foundations and deep foundations. So what makes a foundation considered to be shallow? Well, let's write this down. A shallow foundation is one that has an embedment depth to width ratio approximately less than 4. Okay? Now, what does that mean in mathematical terms? Well, the depth of embedment or embedment depth is how deep into the ground the foundation is embedded into the ground. And then the width is the smaller plan dimension, okay? So in mathematical terms, we can say the depth of embedment, which we'll call d sub f, over b, the least plan dimension, or the width, is approximately less than or equal to 4. So graphically, what would that look like? Well, graphically, we can express this something like this. Let's say that this is our column, and that column is attached to a structure of some sort. And this is our foundation. Let me see if I can draw that a little bit better. Actually, about the same level of not good. Okay, so this is our foundation, and let's say that this is the ground surface. And let's say that there's an applied load here that's like a force coming in from the column. So this depth of embedment is this dimension line here. We'll call that d sub f. So again, that's how deep under the ground surface, this is the ground surface, that the foundation is embedded. And then the width here would be this dimension. And so this view right here, this diagram we're looking at, we're going to call that a profile view, or also you may call it a section view, okay? Profile view, okay? Now, again, we want to emphasize this dimension B here is the smaller plan dimension. So what do we mean by that? Well, let's look at a plan view of what this could look like. So a plan view, if you're familiar with your engineering graphics terms, that's like a bird's eye view. That's like if you're looking down on the foundation. So if I drew a plan view, that may look something like this. Let's make this a little longer here. And then about right in the middle is the column. Okay. And this dimension line B here is going to be right here. And then this other dimension line, what dimension is this? Is this also B? No. Is it d sub f? No. this would be L. That would be the length of the foundation. And so here we're going to say that the length L is the larger of the two plan dimensions. So B is the smaller plan dimension. So we can make a note here. This is a plan view. So again, if you're looking at the profile view, this is like looking at the side of the foundation, and this plan view would be if you're looking at the top, looking from the top down on the foundation. And we're going to put a little note here just to be correct. This is going to be not to scale, NTS, not to scale. So this is in general what we mean by D sub F and B, and the other dimension being L. Now, what are some common types of shallow foundations? Well, let's list some out. Common types of shallow foundations include, spell include right, include spread footings, which actually the diagrams that I just drew, the profile and plan view, that's an example of a spread footing. So spread footings. We also have strip footings. Strip footings. And then we also have what are called mat foundations. So these are probably the most common types of shallow foundations. There's some others out there that exist, but these are the more common ones. And so when it comes to analyzing and designing shallow foundations, what do we need to be considering from an engineering perspective? Well, let's have a little discussion about that and list some of that out. So to analyze and design a shallow foundation, the engineer must consider the following. So we have two broad categories of what we call design limit states that the engineer must consider when they're analyzing or designing any kind of shallow foundation. Now, consideration of design limit states also applies to designing and analyzing other things. But again, for the purposes of this video, we're focusing on shallow foundations. So we have two broad categories when we're dealing with shallow foundations. We've got geotechnical limit states. And then we also have structural limit states. So again, these are the two broad categories. So what do we mean by geotechnical limit states? Well, as a geotechnical engineer, you must consider two very important geotechnical limit states. These are limit states involved with the soil itself, the soil that's beneath and around the foundation. So the first geotechnical limit state that you have to consider is what's called the soil bearing capacity. We sometimes call the soil bearing capacity an ultimate limit state. That's because if the soil fails in its ability to bear the load from the foundation, that could lead to a catastrophic failure of the foundation, right? The foundation will sink or deform into the soil that can cause anything above it that it's supporting to collapse. So soil bearing capacity is one geotechnical limit state that's also known as an ultimate limit state. The second geotechnical limit state is what we call soil settlement. So when we say settlement, we're discussing the idea of the soil rearranging and moving around due to the load from the foundation, which then causes the foundation to settle probably not by much, but settle into the ground, okay? So deform into the ground. So we sometimes call settlement a serviceability limit state. So a geotechnical engineer would be the person who investigates the geotechnical limit states. Now, on the structural engineering side of things, the structural engineer that's involved with designing a foundation has to investigate their own limit states. And there's several of those. So let's list those out. With structural limit states, we have concrete, flexural strength. This is the ability for the concrete itself that the foundation is made out of to bend, to sustain a bending action. We also have concrete one-way shear strength. Okay, this is the ability for the concrete that the foundation is made out of to sustain a shearing effect in one direction, okay, or on one side of the foundation. We also have concrete two-way shear strength. Two-way shear strength in concrete foundations is also sometimes called punching shear strength. This is the ability for the concrete foundation to resist a shearing effect that could cause the column to punch through the foundation pad, okay, or shear in two directions through the foundation padding, okay? So concrete two-way shear strength and one-way shear strength. We also have column to footing bearing strength. So this is the ability for the concrete at the footing column interface, where the column is connected to the top of the footing, to bear the applied load on the concrete pad. So that's the concrete bearing strength at the column to footing interface, okay? And we also have what's called reinforcement development length. So reinforcement, also we sometimes call that rebar. That's the steel that we put into concrete. In this case, it would be the steel that we put in a concrete footing to resist tensile stresses that could develop due to the applied loading. And when you design reinforcement in a concrete structure, you always have to check what's called the development length, which is the length of the rebar required to obtain the full yield strength of the steel rebar. So in some future videos, we're gonna go into each one of these limit states more explicitly with some accompanying calculations, both on the geotechnical side and the structural side. So in this video, it's just meant to give you a conceptual overview of what you're looking for and what you're interested in regarding shallow foundations. So look out for some other videos where we get into some of the nitty-gritty calculations. If this video was helpful for your understanding, your conceptual understanding of shallow foundations, please hit like and subscribe, and look out for our future more technical videos on the subject. Thanks for watching.